let's talk about Newton's second law. Newton's second law states that force equals mass times acceleration. So what does that mean? Well, there's a few relationships we need to consider. One is that if all things are constant, meaning they don't change, then force will equal basically the amount of movement we see from an object. If we change just one of those variables, whether that variable is the force, the mass, or the acceleration, then the whole thing is going to change. If we change the amount of force that we're applying to an object, then we will see a change in its acceleration, its motion that it's going to move. If we leave the force the same and we change the mass of the object, then we should see a change in how much that object moves. All right, so we can set up a couple demonstrations like this, and you can do it at home. I rifled through my house and I managed to find 3 objects, although where my marble went is unclear at the moment. Because here it is, found it, got it. I managed to find 3 different size objects. I have a marble because I'm a science teacher and I guess I have marbles in my bag. I have this tennis ball. I'm not sure why we have a tennis ball, but we do. We don't play tennis. And I have this really old softball that was actually mine when I was a kid playing softball. So I have 3 different spherical objects, so they roll. So we're gonna look at these objects' motions. In this case, you could use like a little car or something, as long as it's going to move, and you can vary its weight, okay, or its mass. So each one of these weighs a different amount. It's not exact science here. I didn't use a scale. I just held them in my hand and said, well, this marble is lighter than this tennis ball, and this tennis ball is lighter than this softball. Now, that means we are changing our mass. So we want to keep force the same, so we can look at how acceleration is affected by changing the mass. So how do we keep force the same? Well, you could blow through a straw. You could just blow on the object yourself and try to use the same amount of force. You could flick it. Or in this case, I happen to find a tiny Nerf gun that my mom sent me for Christmas a couple of years ago, and I'm going to use that to administer the force to the different objects and see how their acceleration changes. So let's take a look. I want to make sure that I'm keeping whatever force I'm applying the same throughout the entire experiment, plus keeping the force that I'm going to apply the same distance from the object itself. So let's start with our greatest mass. Okay, force is constant. We have a greater mass. We're looking at how that changes the acceleration. And in this way, we're going to see acceleration as the motion of the object. All right. So, whoops, misfire. Happens. Gotta move my hand. All right. So we don't really see the largest mass move. So let's see what happens when we apply that force to the medium mass. All right. A little bit more motion. I'm going to retrieve my dart, and let's use the same distance, same force, and see how it affects our marble. Whoop. Okay. So, marble seemed to have the greatest amount of motion, and if we went back in order, marble had the greatest amount of acceleration, the tennis ball had the medium amount of acceleration, and our softball had the least amount of acceleration. So what did we learn? If we keep force the same and we increase our mass, how does acceleration change? Well, what we should see is a heavier object has less acceleration. And that is a perfect demonstration of Newton's second law of motion.